Alrighty, and we're back. 06F-60, equilateral triangle and a circle. So it gives us a distance between the tip of the triangle and the circle, and we know that that distance is 3.87. So I'm going to go ahead and draw a tangent line right here. That's a point of tangency, so it's a 90-degree angle. It also appears that these two lines, uh, that the line from the center of the circle, so the radius, and the line of the height from the triangle appear to be on the same plane. So that means that that also intersects, the base of the triangle intercepts and makes a 90-degree angle. So those are both radius. Those are both radii, I should say. Those are both radii. And we know that that hypotenuse must be the same. So if you look at it, we have two equal triangles, two, I'm pretty sure the right term is congruent triangles. Sorry, again, it takes me a second. It's been years since geometry. But since we know that the two of the legs are both r, right? We know the angle is 90, and we know the hypotenuse is the same. Using angle side side, we know that those two must be congruent. So if this length right here is 3.87, that means that this length right here must also be 3.87. 0.87. And if we double that, what would that be? 7 point, so 80, so that would be a 4. I round up 7.74, it looks like. 7.74. Let me check. 7.74. Alrighty, so that tells us that this entire length then is 7.74. And since it's an equilateral triangle, we can just use the area formula for it. So the formula is just the side length of an equilateral triangle squared times the square root of 3 over 4. And there it is, 25.9. That's our area. If you're curious where that formula is derived from, I can show you real quick. So, as you know, an equilateral triangle has 60-degree angles, okay? Let me draw a 90 degrees angle right there. They're all 60 degrees, and that's bisected, so that's a 30 degree. So if you notice, this is a 30, 60, 90 triangle, okay? And then again, that's supposed to be a right angle right there, but it overlaps. Now, the usefulness of that is if let's say this side length here is x, or I'm gonna call it x halves. If that's x halves, then you know that this height has to be x square root of 3 over 2. Okay? And basically, all you're really doing is to find the area, of course, of a triangle is base times height. So the base, if this is x halves, if just this area is x halves, then you know that the entire length has to be x, right? The entire base is x. You multiply it by the height, which is still x squared of 3 over 2. But you're not done. It's base times height divided by 2. Divided by 2 one more time. And that simplifies to be x squared times the square root of 3 over 4. So that's where you get the formula from, if you're curious. But yeah, pretty simple problem. We went by pretty fast. So thank you for watching. If you enjoyed, please let me know in the comments. If you had a faster way of solving for it, which I'm pretty sure this is the fastest. I know with some of these problems, I reckon there's a faster way, but like, I mean, potentially the first 3 of this set. But for this one, I felt like that was the fastest. I don't think there's a much more optimized way you can attempt it. But yeah, I mean, if you see something, please let me know. Other than that, thank you for watching again, and y'all have a blessed rest of your day. I'll see you tomorrow where we go over 06G-60.